Okay, today let's talk about Leetcode weekly 423 question 4. First part is description. We are given one string s and an integer k. S is a binary representation of number n. So we need to find out how many numbers that can meet requirements. There are two requirements. First is the number should be less than n. So the second will be it can transfer less than k times and become the number into 1. For the operation, for one operation, that means for the number x, we need to transfer it to amount of ones in the binary representation. For example, if x will be 5, the binary representation will be 1, 0, 1. So there are two ones in the binary representation. So we need to transfer the x will be, that means x pair become 2. The two binary representation will be 1, 0. There are only 1, 1 in the binary representation. So we will make it 1. So we need to transfer 2 times, become 5 to 1. So the second requirement means we only need to do the operation less than k times and become the number into 1. Okay, this is the description about this problem. Second part, let's talk about the solution. For this solution, we can talk about the detail, the limitation about the number. That means s star length less than 800 and k less than 5. So we will know after one operation, after one, for the original value will be n. For after one operation, we can make it n1 will be less or equal than 8100 because as the length is less than 8100. So we will know this information. After that, we can split the solution into three parts. First of all, we can calculate how many numbers can meet the requirement from 1 to 2 to the power of 10. Actually, 2 to the power of 10 equal 1024 because this is about value with 8 hundreds. So we can calculate this in the brute force method. We can check every value if it can meet the requirement. If it can, for every value after we do one operation, we can transfer it into this interval. So it's very easy to solve this, the first part. For the second part, we can make another color. For the second part, we can calculate 2 to the power of 10. From 2 to the power of 10 and 2 to the power of s star length minus 1. That means we can process every number whose length between 10 and s star length minus 1. For the third part, we can calculate the amount of numbers which length of binary representation will be s star length. We can sum of the amounts of the three parts. That will be the answer. Okay, let's solve it one by one for every part. Okay, the first part, we will know. We can do it in the brute force method and check every number to determine if it can meet the requirement, we can use the brute force. For the second part, it's an interesting question. For the second part, let's assume the x belong 10 and s star length minus 1. We will know to the power of x, or the value, or the current value is definitely less than n, because the length of power of 2 is less than s star length. So it definitely meets the first requirement. Okay, let's check out how it can meet the second requirement. For every x, we will know the first element of the binary representation of x must be 1, and we don't know the last several bit it will be, but it can be anything. Yeah, because it can be anything, because the first will be 1. After that, we will know the value of it must less than n, and the length must be x. So after that, we can travel the I equal 0 and x minus 1. That means there are I ones in the binary representation of x. So we can assume or value. For every I, we will know we can use the combination and permutation to calculate the amount of numbers that can meet the requirement. That means we can use the C function x minus 1 and I. That means we can choose I bit atoms from x minus 1 bit atoms and set this atom as 1. So C function will return the amount of situations we can choose. Actually, this is the range of combination and permutation. I will not provide details about this method, but the formula of the C function will be, actually, if the C function will be m and n, that means we can choose n atoms from all m atoms. It will be m plus multiply m minus 1 multiply m minus 2 multiply m minus n plus 1. Okay, that will divide it by 1, 2, 3 until n. This is the formula of C function. It means how many situations if we choose n atoms from all m atoms. So what we need is to sum up n equal 0 until I minus 1 C function x. We will choose I atoms from m minus 1. Yeah, this is what we need for the second part. In addition, we also need to calculate, we need to determine if the I minus 1 value, if it can meet the second situation, second requirement. But it is easy because we can calculate the times we need to operation for every value between 1 to 1000. So it's easy to determine if it can meet the requirements, the second requirement. So after that this is how we solve the second part. That is, we can solve the second part. That means we need to use the combination and permutation method to solve the second part. For the third part, if the length of the current number we choose is as same as original number. For example, if the s third part, if the s will be 1 0 0 1 1 0 0 1 1 1 1 0 0. So for the first number, for the first bit value of our choose, it must be 1, because if it is 0, the length will not be as same as original number. For the 0, also the number we choose must be 0, because because it will be, if it is 1, it will larger than, if it was larger than original number n. For the last ones, we can make it as 0. After that, it can be the requirement, it will be less than n. In addition, the last several bit stats, we can make it any number. So it is same with part 2. How we solve it? For example, if we assume the length of it will be len. Okay, we can travel the every I belong 0 and len. What we need to do is sum -1 to len C function. We will choose I atoms from len atoms. Okay, this is how we solve how we calculate the amount of number. Okay, in addition, if it will be the original value will be 1 0 0 1 1 0 0 1 1 1 1 0 0. If the number we choose will be 1 0 0 1, for the second value we also can make it as 0. If it is 0, the last several bits we also can set them with any value 1 or 0. That means we can let's assume it will be p. That means we should assume from 0 to p and choose I atoms from all p atoms. Yeah, this is how we process when the first several when we know the value for first several bit. This is how we calculate the third part. In addition, we also can determine if it can meet the requirement, meet the second requirement. But it is easy to determine that, because after one transformation, we will know the number will become a value between 1 and 1000. So it is easy. So for last part, it will be use bit dp. That means this is how we solve this problem. For the every part, after we process every part, we can sum of them and know the answer. Okay. This is the third part. This is all about the solution. If you have any confusion, welcome to submit a comment. For the last part, let's talk about complexity. For the term complexity, we will know. For the term complexity, for the first part, term complexity will be 1000. Actually, it will be 1024 multiply 4 times, because k is less than 5. Okay, that will be 5. And this is the first part. For the second part, it will be 1000. Actually, it will be 800 to the power of 2, because we need to transfer every length. We can transfer all lengths. For every length, we need to calculate the C function. The time complexity of C function will also be 800. So the time complexity of second part will be 800 to power of 2. It is same. So the finally time complexity will be this value. For the space complexity, we don't need extra space to store the variable, so the space complexity will be 1000. Actually, it's 1024. Okay, this is all about this problem. Thanks for your watching.